Okay, so graphing linear equations. Let's say that we're given a equation in slope-intercept form, and we're asked to graph it. So there's a few steps that we can follow to be able to do that. So first, we're going to make sure our equation is in slope-intercept form, which on these first examples it will be. Then we're going to graph the y-intercept. This is always at the point 0, b, so it's going to be on the y-axis. You're just going to count up or down whatever that b value is. Use the slope of the line to create more points. So slope is rise over run. And then you're going to use a ruler to draw a line that extends through the points and make sure you have an arrow at both ends. So that's important. Alright, so let's start with the first one. So this first example, so it's in slope-intercept form. Our slope is -1. Remember, when there's not a coefficient there, it's understood to be 1. And in this case, it's a -1. And then our b value is 5. So our y-intercept is 5. So the first thing I'm going to do is plot the point 0, 5. That's my y-intercept. So at point 0, 5, I'm going to put a point. Okay. Now with the slope, there's a couple things to remember. So remember that it can be written as -1 over 1. Anytime you have a whole number, we could put it as a fraction with a denominator of a +1. Now, this simplifies to -1, but 1 over -1 also simplifies to a -1. So that means our rise could be a negative and the positive run, or we could do a positive rise and a negative run, and I'll show you what that looks like here in just a second. So first off, let's start with this -1 over 1. That's kind of the most common. So -1 on the top means I'm going to rise in a negative direction 1, and then I am going to run in a positive direction, which is to the right. And then I'm going to go down and to the right, another point, and down and to the right, another point, and down and to the right, another point. Now, from here, I also need to go in the other direction. So this is where this same slope comes into play. I can go in a positive rise and a negative run to continue that line on forever. And of course, you would get a straight edge, and you would connect those points and put your arrows on each end. Okay, so these two things are the same. It's not common for us to have that -1 on the denominator, but I just wanted you to see that if you needed to plot points on either side of your graph, you have that ability to kind of rewrite that -1 as -1 over 1 or 1 over -1. Okay, so let's look at number 3, another example. So here our slope is 2/5, and our y-intercept is 2, or 0, 2. Okay, so with this 2/5, all right, let's keep in mind that a positive divided by a positive is a positive. But if I had a -2 divided by a -5, it would also equal a positive 2/5. So it can be rewritten in another way so that I can continue my points in either direction, and I'll show you what that means. So we start with our y-intercept, so 0, 2. Now, I'm going to start by using this +2 over +5. That's my regular slope. So I'm going to go up 2 and to the right 5. Now, if I try to go up 2 and to the right again, I'm going to be off the grid, but I need more than 2 points in order to graph this. So I'm going to use this, which is equivalent. They're exactly the same thing. If I put it in my calculator, 2 divided by 5 and -2 divided by -5, I'm going to get exactly the same answer. Okay, so this allows me to go down 2 and to the left 5 to create one more point so that I can connect them and put my arrows. Okay, so doing those equivalent fractions allows me to have enough points to connect and make our lines. Okay, so let's look at one more example here. Look at number 5. We have a slope of 2, which can be written as 2 over 1, and a y-intercept of 6, which is the point 0, 6. Okay, remember that 2 over 1 can also be written as -2 divided by -1. So that's going to come in handy when I start to graph this. So I'm going to start with point 0, 6. So immediately, I notice that if I go up 2 and over 1, I'm already off the grid. So that's where I'm going to need this -2 and -1. I'm going to go down 2 into the left 1, down 2 into the left 1, and continue that until I have enough points to graph. And so my line is going to look something like that. Okay, and that's where, don't forget to put your arrows on each end. another example. Let's see what this looks like. So here I have a slope. Remember, slope is our coefficient. So m is equal to -4 or -4/1, and our y-intercept is 0. There's not a constant out here plus whatever, so that means that our y-intercept is at the point 0, 0. Now we do need an equivalent fraction for -4/1. I do need to have one of these numbers to be a negative, so I'm going to flip it and let it be negative on the bottom and positive on the top. It's still going to give me a -4 either way. I haven't changed the value of the slope, just writing it in another way to be able to do my rise over run. So I'm going to start with my my y-intercept, and I put a point at 0, 0. Now I'm going to go ahead and do this -4/1. So that means I go down 4 and to the right 1. And then I can't go down 4 and to the right anymore. I'm off the grid. So I'm going to come back up here and I'm going to do a +4. So up 4 and to the left 1. Okay, and so just as a reminder, with our slope, if we are going up, it's going to be a positive number. Down, it's going to be a negative number on the top for our rise. Okay, for our run, if you're going to the right, it's going to be a positive number. If you're going to the left, it's going to be a negative number, and that's our run. So that's important for you to remember. All right, and then I can't go go any further on the grid, so I'm going to go ahead and connect my points and put my arrows at the end. All right, one more. So this one has been rewritten as y equals b plus mx. Just kind of switched it around a little bit. The constant is still the y-intercept. The coefficient to the x is still the slope. So that means that my slope here is -6/5, and my y-intercept is a +1. That negative goes with the 6/5. This 1 over here is positive. So 0, 1 is going to be my y-intercept. My slope, written as -6/5, I can flip those that negative and also write it as 6 over -5, just to help me out for that equivalent fraction. Alright, so 0, 1 is going to be my y-intercept, and then I'm going to go here -6, which is to the down, and to the right 5, and that's where my first point is going to be. Then I need to go backwards, so I'm going to go up 6, and I'm already off the grid, and then I'm going to go to the left 5, just so I have kind of an idea of where to make this line. And I'm going to go ahead and connect it and put in my arrows. Okay, and so that's just kind of the basics for graphing a linear function using that slope-intercept. And again, if you have questions, you've got these 4 examples that you can do on your own. Let me know if you have questions, and I'll be happy to answer them. Just let me know.